Let's get started. All right, so we're going to do decomposition and synthesis. Okay, so let's start with decomposition. All right, let's start with decomposition. All right, made my C a little bit too closed. And generally, it's going to be you have a compound. This is a compound, and this is either an element and an element, or an element and a compound, or a compound plus a compound. Either way, there's not any one way to say it. It's either an element and a compound or a compound and a compound. Okay? Yes? Or two compounds. And I will show you examples of that. Okay? I'll show you examples of that. Now, so there are six kinds of reactions that are obvious. There's six that are obvious. The first one is probably the easiest one to understand. If I take a compound, I break it down into its elements. What compound do you automatically think that you can do that to? Anything. Just give me an example. You take a compound and you separate it into two elements. Anybody have an idea? What is it?
H2O.
What is it?
H2O.
H2O, I like that, water, breaks down into what?
Hydrogen and oxygen gases.
Where did you learn that?
Yes, sir.
Where? Okay. Anybody else knew that? Did anybody else know that? Yes. Jordan teaches it. Excellent. We like Jordan. Okay. America, thank you. That's really nice. We have a representative from America. Anybody else? No? Yeah? Denmark, God bless Denmark. Excellent. Excellent. Ethiopia? No? I think they did. You may not have heard it. But anyway, that's right. You take the first kind is when you take an element and a compound and you break it down into its elements. Okay? For instance, if I take water, I break it down into hydrogen and oxygen. Let's just talk a little bit about that. Water does not conduct electricity. Did you know that? Water does not conduct electricity. Things that are dissolved in water will conduct electricity, but water does not conduct electricity. And the way you separate water into its elemental parts is through using electricity. So how do they do that then? How do they do that?
Electrolysis. Yeah.
Electrophoresis, is that what you meant?
Yeah, sometimes.
No, not electrophoresis, no.
We did an experiment in my old school where there's tubes and stuff, and
Yeah.
it separated and made hydrogen, and then you burn it.
And oxygen. That may have been a Hoffman apparatus. Well, what they do is they put salt in, sodium nitrate, some kind of salt, and then they run an electric current, and you produce hydrogen and oxygen. Right? How would you separate sodium and chlorine from sodium chloride? Same way. But can you do it? How would you do it? Because if you put the sodium chloride in water, the water separates. So how would you do that? You need a solution or a liquid, something. How would you separate sodium and chlorine into its elemental parts? What do you think?
You dissolve it in water, and then.
Yeah, if you dissolve it in water, it's the hydrogen, it's the oxygen that's going to decompose, not the sodium chloride. So what would you do?
Dissolve it in.
No, don't think dissolving. Think in a particular environment, you have to take all the oxygen. You can't do it in air. You melt it.
Melt.
And then send a current through a molten form of sodium chloride.
Isn't it very difficult to melt sodium chloride because it has a high.
It has a very high melting point, but it doesn't have an infinite melting point. But it has a high melting point. So you'd have to maybe, I don't know how they do it. I haven't looked at the specs in a long time, but I don't know, possibly in an argon environment. Argon doesn't react, right? So could be. I don't know, but they don't melt it in water. I mean, that's for sure. It has to be pure. or in an environment that's not going to react with the sodium and chlorine. If you try to melt sodium chloride in air, what happens? The air reacts, it decomposes, right? Yeah, it decomposes. Yeah. But it doesn't decompose into sodium and chlorine. It decomposes into other things that it reacts with in the air. Yeah. Okay, so that's the first one. You have a compound and you separate it into its elemental form. Okay. Now let's see, what's another one? If I take an acid, if I take an acid, such as, we did this one before, I break that down into carbon dioxide and water. So the way you label this is, the first one is a compound that you break down to its elemental forms, right? The next one is an acid. This is an acid. This is an acid, what? What's that called? An acid what? Acid what? What is carbon dioxide? What is a non-metal oxide called? We did this. What's a non-metal oxide called?
Base?
No. An acid anhydride. Okay? An acid anhydride is a non-metal oxide. So you take acid and you decompose it into acid anhydride. Clear? Shall we do another example of that?
Sure.
Do another example of that? We have, this is one you're going to have to balance, and it's a tricky one too, to balance. But once you get it, it's going to be like obvious. Yeah. And that's going to be P2O5 plus water. So the acid anhydride that corresponds to PO4 is P2O5. Diphosphorus pentoxide is the acid anhydride that usually corresponds to PO4. Okay? So how would you balance that? You have 4 over here and 6 over here. What would you do?
Put a 6 over there, 4 over there.
Put a 6 over here?
Yeah.
Put a 6 over here?
Yeah.
That would be 24 oxygens?
And then you put 4 by,
No, you can just do 4 and 3. Wait, 3.
I don't understand. You're going to have to give me some.
3 in the left and
3 here?
Yeah, and 2 at the left.
You saw that quickly. And
2 at the
a 2 here?
right. 3.
That would be right?
No, no.
Oh, a 2 here?
Yeah.
A 2 here?
Wait, no.
That would be
Wait,
11.
if you put a 2 on
On the
the
whole thing?
H3PO4.
A
and then
2
you put
here?
Yeah, and then you put a 3 by the H2O.
Yeah.
That
Then
sounds-
hold it. Let me do that. Okay, so put a 2 here
So it's 8.
and a 3 here.
That solves the hydrogen problem, but then,
Not the oxygen.
let's see. For oxygen, you put, there's a 6 there.
Count though. Count. The oxygens are in 2 places, so count them.
So there's 6 oxygen on one
There's
side.
5 and 3 is 8. And
Oh,
2 times 4 is 8, so the oxygen's balanced.
Yeah.
See, the thing about balancing equations when an element is in 2 places on the same side, that sometimes is tricky, but you've actually balanced that equation. Very good, very well done. Three tries. I'm very impressed. Very impressed. Okay, so let me erase these here, just this one here for a second. So what you would say is you have various acids. 3PO4. Can I just write down the polyatomic ion instead of putting the acids? Is that okay? Because sometimes you don't really need, just as long as you have the polyatomic ion. So in other words, CO2, PO4, NO3, NO2. This goes to CO2, sorry. What's wrong with my brain? That goes to CO2. This goes to P2O5. This goes to N2O5. This goes to N2O3. So these are the corresponding acid anhydrides. And what I'll do is, this is a little sloppy and all thrown together. I'll put them up on the board so they're obvious. Okay? But you have several that you should commit to memory. Even though I don't make you commit to memory, because I'll give you a chart with it on. So you should put those in your notes. Yeah? Okay? Yes?
So the reason why it's acid anhydride, is it because it's the same acid just without the hydrogen?
No, you take the water out of it. You simply take the water out. You know, phosphoric acid is diphosphorus pentoxide plus the water. The water is part of it. So you take the water out and you're left with the acid anhydride. It is not any more complicated than that. So I've given you two, right? Yes, I've given you two. The next one would be if I have a base. How would you, let's see, I'm not quite sure I want to say what's the definition of a base, but how do you recognize a base? What's the dead giveaway to recognize a base? Like if I said to you, this is a base, you would say to me, well, what's the formula for a base? And then you see the formula for a base and you say, I know it's a base. Come on.
Ends in OH.
Yeah, OH. The presence of the polyatomic ion OH means base. Okay? So what do you think that's going to break down to? What do you think? Let's see. Let me think. So an acid breaks down into an acid anhydride in water. A base would break down to a what? A base anhydride in water, right? Doesn't that make sense? An acid breaks down to a acid anhydride in water, and a base breaks down to an acid anhydride in water. What's the definition of an acid anhydride? What's an acid anhydride?
The acid without the water.
I'm sorry, a base anhydride. Did I just say acid? Sorry. What's the definition of a base anhydride?
Base without the water.
This is what I see. You ready? I have no idea what you're saying.
The base without the water?
Yes, but give me a definition, something I can walk away from and being something very useful. If I was Abe, I'd say, well, how do I spot? How do I know something's a base anhydride? What would it be? How would I spot that? Give me an example. What's a base anhydride? What is it?
Does it have to have a metal?
Yeah, well, considering that that's the base metal hydroxide, I'd say yeah. So it would be a metal,
And water?
no, a metal,
Hydroxide.
Look, try to make some connections here. An acid anhydride is a non-metal oxide. A base anhydride might be a
Metal oxide.
metal oxide, right? Correct?
Right.
Okay, so and that's what it is. What's the formula for magnesium oxide?
MgO.
Very good, 2 and 2, right? Perfect. Anybody ever hear of milk of magnesia? I mean, is that like an American thing, you know, blue bottle, you know, you got some stomach problems maybe, you're a little constipated or something, or whatever it's used for. You take milk of magnesia. Anybody ever hear that? No? Like this horrible white, bleh. No, never heard of milk of magnesia? When they teach in America, everybody's heard of milk of magnesia. Maybe it's like an American thing. Anyway, milk of magnesia is magnesium hydroxide. So you put water in it. It's a powder. You put water in it, and you take that if you're sick. Has a lot of good medicinal. But don't go and make magnesium oxide and then put water in it and then take that. I'm not recommending that. Okay. All right, what's another one? Let's see. We did a base, an acid. All right, I know. You ready? This is a great one. This is how you, very dangerous way, but you can do it under safe circumstances. You can make oxygen using this type of chemical as a generator. So you put this chemical into a test tube and you heat it and it produces this gas. Anybody know? Doesn't do anything for anybody? okay? If you take a chlorate, any chlorate, sodium chlorate, magnesium chlorate, barium chlorate, right? And you heat it, you produce, what two things would you produce, do you think?
Salt,
Yes, but what's the name of the salt here?
NaCl, table salt.
Yeah, sodium chloride.
And
You shouldn't say table salt because I take, well, I don't take as much as I should, like potassium chloride I use. It's better for your heart. I'm getting old, yeah. So don't say table salts, you know. Sodium chloride, that's better. And what?
oxygen gas.
How would you balance that?
You put it
2 and 3, right?
Yeah.
Exactly. Chlorates are generally pretty easy to balance, yeah? Easy?
Still not balanced. They have to put it.
Still not balanced?
Two by
What
the
do you need to do?
2 by the NaCl. Yeah.
2 by the NaCl? Very good. All right, what else? Let's see, so we've done a compound to its elements, yes? We've done an acid, we've done a base, we've done a chlorate. Pretty good? Yes? All right, let's do different kinds of, let's do a carbonate. Carbonate, yes? Can we do carbonate? Okay, so if I take a carbonate, something we've done before, okay, like sodium carbonate. Sodium carbonate. Sodium, what? What am I doing? It says, I left out an A, huh? Let's say sodium carbonate. What's that going to break down to? A sodium carbonate. What's that going to break down to? Sodium
CO2
carbonate.
And sodium oxide.
What is it?
CO2 and sodium oxide.
Yeah, sodium oxide plus
Carbon dioxide.
CO2. Okay, what's that? Going to equal. How would is that balanced?
Okay.
Yeah, it's balanced. So what have we done? We've done a compound to its elements. We did an acid to acid anhydride and water. We did base to a, you can do it, a base to a base to a base to a
anhydride. Base anhydride.
a base to a
Base anhydride and water.
base anhydride and water. We did, what was the next one we did?
A chlorate.
A chlorate. Yes? Correct?
Yeah.
Is that good? All right. The next one we're going to look at is going to be, let's see, would probably be, let's not worry about that one right now. I want to make sure that this is taping correctly. We'll come back and do it, okay? Yes? And then what do we have left besides this? We have the sixth one to do, and then we have what? Synthesis. And then the fifth one, the book says 5, not 4. I don't know where my brain was. Then we're going to do combustion, okay? And we're going to finish today. Clear? Is that good? All right.